Hi, you're listening to episode 11 of Virtualized Geeks Tech Talk. Today is April the 30th. I'm recording a day later because I wanted to talk about network virtualization tonight, and I wanted to give my blog post a little bit time to marinate, the one that kind of goes with this video. If you have been paying any attention to Virtualized Geek in the past couple of weeks, I've been really focusing a lot on SDN. I actually wrote a blog post over on searchnetwork.com about SDN and specifically network virtualization, and if VMware was going to make Cisco irrelevant at some point. It was a little bit tongue-in-cheek. Cisco, of course, won't become irrelevant. It was more of a stab at VMware about its aggressive approach to marketing and disrupting various markets they go into. They announced a few weeks ago, or a couple of months ago rather, that they were going to roll out their own hybrid cloud. They've been extremely disruptive, obviously, in the server space with their virtualization solution. Servers are now probably a commodity, mainly because of the technologies that they've pushed on the x86 end of the spectrum. Now companies like Dell, HP have to completely change courses. IBM recently, or is rumored to want to sell their server business to Lenovo or to anyone for that matter. This is all because, just like the PC industry, the server business has become commoditized. So I kind of fast forward the frames a few years into the future and said, what will the world look like with a VMware completely engaged in what they are pursuing with their Nicira acquisition and the whole concept of a software-defined data center? So, you start with virtualization from the x86 perspective. You completely turn the way that we deliver x86 services to our customers within the data center completely on its head. Now we can do really cool stuff from operations side. We can put applications on all kinds of hardware. We really don't know, without looking at a console, really what physical server is running what application at any moment. DRS and technologies similar to DRS allow us to automatically vMotion machines from one piece of hardware to another piece of physical hardware based on the distributed load of your cluster. So we've completely changed how we approach x86 service delivery, and similarly, VMware is looking to change the network world on its head with network virtualization. I had a little bit difficult time kind of wrapping my head around network virtualization. The big difference for me was the physical layer. There's a big difference between kind of x86 virtualization versus network virtualization. You're kind of servicing two different crowds with the different technology and delivery approaches. With x86 virtualization, it's pretty simple. You're providing independent operating systems based on independent hardware to applications. So you've abstracted the physical hardware from the application, provided that abstracted operating system or abstracted set of hardware to an operating system, which is presented to the application. When you think about abstracting the network from physical hardware, that gets a little bit more confusing. You think about a physical piece of networking gear. A physical piece of networking gear has to connect to the endpoints that it services. So how do you abstract the connectivity of a endpoint, whether it's a piece of server hardware, another piece of networking gear, or an end user piece of equipment? How do you abstract that? or how do you create abstraction from that, from the physical device? So after doing a bit of digging, a bit of reading, I relooked at VMware's announcement from their blog for the NSX solution, their hypervisor-based virtual network solution. And really, I kind of, there's a picture on that site that really put it all together for me. I'll add the picture to the show notes on virtualizedgeek.com, or better yet, I'll just reference my blog post on network virtualization as I understand it. The concept is actually pretty simple when you think about it. You're abstracting not the connectivity, but the concepts of the devices. So from an x86 perspective, we've abstracted the concept of what is server hardware from the underlying hardware and built virtual hardware. In the networking world, same thing. We've abstracted the switch, router, IDS, whatever networking gear you want to, the firewall, we've abstracted that from the physical connectivity and from the physical layer and create logical representations of these devices. So you have a logical firewall, you have a logical router, you can have a logical switch, and underneath that, the underneath layer of that is the physical connectivity. So you have some sort of physical connectivity still, but you can think of that more as a dumb conduit, or a conduit that allows the entire network to touch itself. So you might have a 24 port access device. We won't call it a switch. We'll call it a regular x86. It can be an x86 dumb device that has Ethernet connectivity. Once you get that layered connectivity into the physical device, and the interconnects connected all together, that's where the physical layer can be abstracted from. So you can have port 1 on physical device 1. It can be connected to a virtual switch. It can be connected to it can be trunked to another physical switch. It can be a physical server. That port is the part that gets abstracted. The hypervisor can now assign that port to any physical or any logical network device within the hypervisor. So let's say you have a virtual firewall, and that port 1 that's connected to a web server can be port 1 or port 0 on your virtual firewall. Now I can apply rules to that, and port 2 on a virtual firewall can be on a completely different hardware layer. So you can have a 48 port access switch on the other end of your data center, or even in a completely different data center. Since it's virtualized from a virtual sense, it can be on the same virtual firewall. That completely changes how we approach networking. The question, there may be marketing questions or actually practical questions about whether or not the underlying physical hardware can give the performance needed to rival traditional data center fabrics. But the paradigm shift in how we think about deploying and managing networks completely changes. Now all of the advantages that we had in x86 virtualization, we now have in virtual networking. We can use commoditized hardware. We can use standard configurations that can be copied from one network device to another logical network device. We can pause, rewind, i.e. we can snapshot, revert back to configurations. We can deploy templates, all of the tools that we're used to in our virtual server infrastructure, we now have available from a management perspective in our virtual network. Again, the argument is, how is this better than like a Cisco One approach to network and network management? How does it compared to a Juniper data center fabric, their data center fabric approach? They address a lot of these types of complexities in their solutions. It may not give you the port level flexibility that the virtual solution gives you, and you may not be able to run it over commodity hardware, but I'm thinking cost. There's going to be a cost performance benefit when it comes to virtualized networking or network virtualization. This is actually a pretty exciting time in networking for me personally. I haven't really touched networking to this level in quite some time. It just hasn't been interesting to me, but this whole concept of network virtualization, or changing not just network virtualization, but changing the way you manage the network from a protocol-centric perspective to more of a logical SDN perspective is all exciting stuff to me. And this sub-layer of network virtualization is really, really good geeky stuff. I hope you enjoyed episode 11 of Virtualized Geek Tech Talks. We will talk to you again next week on yet whatever topic comes to mind. Thanks and have a great week.